Imagine eating like a handful of premium almonds. You're meticulously logging those 200 calories into your fitness app, but your body functionally absorbs almost zero of them.
Right, yeah. It's
I mean, the fats and proteins literally pass right through you, completely unabsorbed. It's a phenomenon that gastroenterology researchers vividly refer to as fecal fat loss.
Which just sounds like a metabolic glitch, honestly, but it happens constantly. We have this tendency to view nutrition as, a simple accounting ledger. Like you input a certain amount of food and your body automatically extracts the value.
Right, a simple math equation.
Exactly. But human digestion is entirely dependent on a mechanical step that, well, most of us completely bypass.
Which brings us to the core of today's deep dive.
Mhm.
We are looking at a really fascinating intersection of modern in vitro food science, gastroenterology, and ancient Ayurvedic texts. And the mission here is to understand why the physical breakdown of our food is actually the central domino in human health. There is a great quote in our sources from Dr. Karan Rajan, he's a clinical surgeon in the UK, who points out that most people chew a few times, swallow a partially intact Lego brick of food, and then wonder why their gut is in absolute agony.
The Lego brick visual is so accurate, because it really exposes a massive misunderstanding about what the stomach is actually designed to do.
Yeah.
People basically treat their stomachs like industrial incinerators.
I have to admit, I completely fall into that camp. Isn't the stomach essentially just like a vat of hydrochloric acid?
Well, sort of.
Because from a purely lifestyle perspective, I've always assumed it doesn't really matter if I swallow a Lego brick of food. The stomach is just going to melt it down anyway, like a biological blender, right?
Yeah, that's the common myth. The stomach is acidic, sure, but it is not a magical dissolving chamber. True digestion doesn't begin when food hits the gastric juices. It actually begins in the oropharyngeal cavity.
Meaning your mouth.
Exactly. In clinical research, we call this the cephalic phase of nutrition. The literal moment your teeth begin to mechanically grind food, your vagus nerve senses that physical pressure.
Oh, wow. Just from the pressure.
Just from the pressure. And it immediately sends autonomic and endocrine signals down your entire digestive tract, basically preparing all your organs for the specific type of food you are eating.
So skipping that step means the lower organs are essentially flying blind.
100%.
We actually have an incredible study in our sources from Wageningen University that quantifies exactly how much we handicap our digestion when we skip that chewing phase. They ran an in vitro study on rice.
Yeah, this study is fascinating.
Right, so when rice was chewed 40 times instead of just 5 times, the bolus particles, which are basically the clumps of food you swallow, were 26 to 47% smaller.
And we really have to look at what that size reduction does on a chemical level. By breaking a grain of rice down into a fraction of its original size, you exponentially increase its surface area. The researchers noted a massive 14% increase in early starch hydrolysis.
Okay, we should probably clarify starch hydrolysis for anyone not spending their weekends reading chemistry journals.
Good call.
It's essentially just water and salivary enzymes breaking down the molecular bonds of the carbohydrates, right?
That's the perfect way to put it, yeah. The enzymes in your saliva need physical space to attach to the food molecules. If you swallow a giant clump of rice, the enzymes can only work on the outside layer.
Because the inside of that clump is protected.
Exactly. But by chewing 40 times, you give those salivary enzymes so much surface area to work on that the food is practically pre-digested before it even enters your esophagus.
So the mechanical effort in the mouth offloads the chemical burden on the stomach. That makes total sense.
Yeah, it does.
But if the physical breakdown prepares the stomach, it seems like the pacing of that breakdown fundamentally alters the brain's response to food, too. The sources highlight a really profound shift in the nervous system when we just slow down.
Right, because the autonomic nervous system dictates our metabolic state. When you inhale a sandwich at your desk in 5 minutes, your body leans heavily into a sympathetic state.
The fight or flight mode.
Exactly, your fight or flight panic mode. Blood is routed to your extremities, your heart rate elevates, and your digestive organs are essentially starved of resources.
Because the body thinks you are fueling up to run from a predator, not, trying to absorb a turkey club.
Yeah, precisely. But the act of chewing repeatedly actually forces a physiological shift into a parasympathetic state. That's the rest and digest mode. Your stomach relaxes, and blood flow to the gut drastically increases to handle nutrient absorption.
And the pacing is just as important as the blood flow, right? Because I was reading that your body requires a standard delay of about 20 to 40 minutes to release satiety hormones.
Yes, If you eat too fast, you literally outpace your own biology.
It's like having a painfully slow internet connection when you're trying to buy something online.
Oh, I love this analogy.
You click the purchase button, nothing happens. So you click it 20 more times in frustration. Suddenly the page loads, and you've accidentally bought 20 pairs of shoes.
Yes.
If you eat too fast, you are clicking purchase 20 times. You end up consuming thousands of calories before the fullness page even loads in your brain.
That is the exact mechanism behind overeating. And this brings us back to Dr. Rajan's framework. He refers to thorough chewing as hormonal foreplay for the digestive system.
Hormonal foreplay, that is quite a term.
It is, but it fits perfectly. The combination of activating taste receptors on the tongue and stretch receptors in the stomach triggers the release of a highly specific cascade of appetite hormones, namely CCK, PYY, and GLP-1.
Wait, GLP-1. Because that is everywhere in the lifestyle space right now. It's the target of all those major weight loss drugs.
Exactly.
Yeah, people are injecting medications to stimulate it, but the research implies we can trigger it naturally just by changing the physical structure of our food before we swallow.
We can trigger it naturally, provided we do the mechanical work. GLP-1 is a gut hormone that signals profound fullness to your brain and actively slows down gastric emptying. The more you chew, the more you secrete.
Wow.
Yeah, and the sources include a fascinating paper from the Journal of Nutrition and Health Sciences looking at tree nuts. They found that only fatty acids with chain lengths of C12 or higher, which tree nuts are packed with, effectively release CCK and GLP-1.
However, I remember the study makes a really crucial distinction about the form of the nut. Chewing whole peanuts suppresses hunger far better and for much longer than eating the exact equivalent caloric amount of peanut butter.
Right.
Which initially seems counterintuitive to me. Peanut butter is just pre-chewed peanuts. Shouldn't it be easier for the body to access those fats and trigger the GLP-1?
You'd think so, but it comes down to the necessity of mechanical disruption. Plants have a really rigid cellular armor. The study specifically mentions parenchymal cell walls. These are thick, fibrous structures that basically encapsulate the nutrients.
Okay.
When you chew a whole nut, your teeth physically crush those cell walls. That specific, targeted mechanical destruction is completely required to liberate the lipids and proteins inside.
So if you don't crush that armor, the body just can't access the fat.
Exactly.
Which brings us right back to that fecal fat loss concept we started with. The intact cells travel your entire digestive tract without giving up their nutrients, and your system just passes them as waste. You ate the calories, but your body registered absolutely nothing.
Because the physical matrix of the food dictates its metabolic destiny. You cannot bypass the mechanical breakdown and expect the chemical breakdown to save you.
It's just crazy to think about. I mean, modern gastroenterology is incredibly sophisticated with all these in vitro models and hormone tracking. But diving into the lifestyle and historical sources here reveals something honestly fascinating. Traditional medicine mapped this out thousands of years before we knew what a GLP-1 hormone was.
Oh, easily.
The sources include a deep look at Ayurveda, and it turns out ancient Indian medicine operates on the exact same physiological principles we just discussed.
The parallels between the ancient frameworks and modern biomedical observations are remarkably precise.
There is a piece from the Arojam blog in Arsak where the author reflects on his grandmother's mantra to drink your food.
Yes, I saw that.
The instruction was to chew every single bite 32 times until it was completely liquid. The author notes that failing to do this is like paying for a full dinner but receiving a pickle.
That's a great way to phrase it.
You simply aren't getting the nutritional value you paid for. And in Ayurvedic texts, this progression of digestion is systematized through a concept called avastapaka, which translates to the 3 sequential stages of digestion.
And if we lay the Avastapaka framework over a modern gastrointestinal chart, the alignment is undeniable.
Let's trace it for the listener. So the first stage is Makura, which is governed by the Kapha dosha. Kapha is associated with earth and water, carrying heavy, moistening qualities. According to the text, Makura occurs in the mouth and the upper stomach. Its entire purpose is moistening and liquefying the food to create ahara rasa, or the food essence.
And in a modern clinical setting, Mathura is just the cephalic phase. It is the exact process of salivary amylase mixing with the food bolus, aided by early gastric churning to create a liquid chyme.
Then the food moves to the second stage, amla. This is governed by the pitta dosha, fire and water. It takes place in the stomach and small intestine, characterized by intense sourness, heat, and acidity.
which perfectly describes the moment hydrochloric acid, pepsin, and pancreatic juices flood the small intestine for heavy enzymatic breakdown.
Finally, we get to the third stage, which is Ka2, governed by the Vata dosha, representing air, space, movement, and drying. This occurs in the large intestine. The texts describe its focus as water absorption, drying out the remaining waste, and utilizing downward movement for elimination.
And that is a flawless description of colon function and peristaltic movement.
The texts also heavily emphasize two concepts: Agni, the digestive fire, and Scrotus, the bodily channels. Now, in the wellness space, these terms are often treated as spiritual or poetic metaphors. But looking at the clinical research, they seem incredibly literal.
Oh, they are entirely literal. When an Ayurvedic practitioner evaluates your Agni, they are evaluating your metabolic enzymes and gastric acids. A diagnosis of weak Agni in Ayurveda is treated by a modern gastroenterologist as hypochlorhydria.
Which is low stomach acid, right?
Right, or a pancreatic enzyme deficiency.
And what about the Scrotus, the channels where nourishment flows?
The primary Scrotus map directly to the Anavaha, which is the physical digestive tract, and the Rasavaha, the nutrient absorption pathways in our plasma. Ayurveda teaches that a blockage in the Scrotus starves the bodily tissues. Modern medicine literally calls that a malabsorption syndrome. We use different vocabulary, but we are diagnosing the exact same physiological dysfunctions.
It's mind-blowing. So, tracking the food from the mechanical triggers in the mouth through the hormonal avastapaka stages leads us to the deep gut. And this is where the physical structure of what we swallow, the bolus, creates some incredibly complex downstream effects.
Yes, it really does.
To understand this, we have to look at a highly technical study from the Riddit Institute in New Zealand regarding the gastric emptying of food gels.
The Riddit study is just a brilliant piece of engineering. They used whey protein emulsion gels as a standardized stand-in for chewed food, and they placed these gels into a human gastric simulator, which is this highly advanced machine designed to mimic the exact biochemical churning and acidic environment of a real human stomach.
Right, and they tested two specific consistencies. Soft gels, representing food you took the time to chew thoroughly into a liquid state, and hard gels, representing those poorly chewed, swallowed whole Lego bricks we talked about. Logically, you would assume the softer food empties from the stomach faster because it's already broken down.
You would assume that, yeah, but the data showed a massive paradox. During the first 120 minutes of digestion, the larger particles of the soft gel actually emptied from the stomach slower than the hard gel particles.
Wait, why would the stomach hold on to the softer, easier to digest food longer?
Because the stomach's emptying mechanism is a highly sensitive sensory environment. The soft gel was actively disintegrating and interacting with the pepsin enzymes. The stomach sensors detected this highly productive chemical breakdown and essentially clamped down.
Oh, interesting.
Yeah, holding onto the food to ensure it was processed thoroughly before releasing it to the intestines. The hard gel chunks, however, resisted the enzymes entirely. The stomach couldn't penetrate them, so initially they just tumbled around and emptied out.
Wow.
Later on, the soft gel emptying sped up dramatically because the job was finished, while those hard chunks eventually caused delayed blockages.
So the stomach actively prioritizes food it can actually work with.
Exactly.
That brings up a massive unresolved tension from the Wageningen and Rice study we discussed earlier, though. Because I noticed something in the data that seems to contradict everything we've established.
Oh, what's that?
The study explicitly states that the less chewed rice actually resulted in higher total short-chain fatty acid levels, SCFAs, and higher bile salt hydrolase activity in the gut. Now, in every lifestyle space and nutrition article, SCFAs are framed as the holy grail of gut health. They reduce inflammation, they feed our gut lining.
Right, they do.
So if swallowing unchewed food produces more of them, shouldn't I just swallow my rice whole?
That's a brilliant observation, but it highlights the extreme nuance required when manipulating the microbiome. The unchewed rice did produce more short-chain fatty acids. But to understand why that is actually dangerous, we have to look at where those acids were produced and the ecological chaos it causes.
Okay, break down the geography of that for me.
When you chew poorly, you swallow large, intact particles. Just like the hard gels in the human gastric simulator, the stomach and small intestine cannot penetrate them. So, these massive carbohydrate blocks bypass the early digestive stages entirely. They arrive directly in the lower gut, the large intestine.
The Ka2 stage in Ayurvedic terms, the drying and elimination zone.
Yes. And the large intestine is home to your deep gut microbiome. Suddenly, these bacteria are presented with a massive buffet of undigested substrate that was supposed to be absorbed hours ago in the small intestine. So the bacteria go into a feeding frenzy. They aggressively ferment this massive volume of undigested food.
And that excessive fermentation is what spikes the SCFA production.
It does, but at a severe cost. While SCFAs are beneficial in stable amounts, this rapid, uncontrolled fermentation causes massive bacterial overgrowth. When bacteria ferment large volumes of carbohydrates, they produce insane amounts of gas. Yeah, this leads to severe bloating, cramping, and motility issues. You are essentially throwing the entire bacterial ecosystem way out of balance.
So it really is a real estate problem.
Yeah.
You are taking a digestive job meant for the small intestine and dumping it into the large intestine, and the bacteria there just riot. By chewing poorly, we alter our entire microbiome metabolism simply because we sent the food to the wrong zip code.
The physical size of the bolus dictates its anatomical destination. It is that simple and honestly that profound.
Up to this point, we've focused heavily on the gastrointestinal tract. But looking through the aerojam and clinical sources, the mechanical act of chewing has systemic, full-body benefits that extend far beyond the stomach.
Oh, absolutely.
For instance, the simple biomechanics of moving your jaw significantly increases blood flow to the brain. How does an up and down jaw movement accomplish that?
It's all about the masseter muscle, the primary muscle used for chewing. It basically acts as a localized hemodynamic pump. The physical compression and relaxation of the jaw muscles and surrounding blood vessels actively pushes blood upward toward the cerebral cortex.
Oh, wow.
Yeah, it's a mechanical lever that enhances vascular flow to the brain, which is why researchers actually link robust mastication to improved cognitive function and even a delay in memory loss for aging adults.
So it is an actual circulatory workout.
Yeah.
And the chemical benefits of saliva are equally complex. The act of chewing stimulates the production of epidermal growth factor, or EGF. The clinical literature refers to this as a polypeptide in your saliva.
Right, and a polypeptide is essentially just a small chain of amino acids. You can think of it as a biological text message. When you chew, your saliva produces this EGF, and as you swallow, it travels down and delivers a message to the epithelial tissue lining your gut, instructing those cells to grow, repair, and fortify themselves.
That's amazing. Chewing actively heals the microscopic lining of your stomach.
Yes, it does.
We are also producing peroxidase in that saliva, which the research indicates actively inhibits carcinogens present in our food. We are neutralizing toxins in our mouth before they can even reach our organs.
Exactly.
But the most striking systemic benefit is what chewing does to our immune system. A joint study conducted by the University of Manchester and the National Institutes of Health discovered that the mechanical act of mastication activates a specific subset of immune cells called Th17 cells, located directly in the mouth.
And what makes this discovery so vital is that usually immune cells are reactive. They wait for a threat like a virus or a pathogenic bacteria to enter the body before they mount a defense. But Dr. Joanne Conkle, who led the research, found that the mouth operates on a completely different paradigm.
The Th17 cells are stimulated independent of any germs, right? It's purely the mechanical friction of chewing. The pressure on the gums triggers the immune system. It kind of reminds me of the calluses forming on a guitarist's fingers.
Yes, exactly.
The mechanical stress and friction signal the tissue that it needs to toughen up its defenses, because the body knows that an influx of food inherently brings a heavy microbial load with it.
The mechanical stress literally prepares the biological defense. If you don't provide the friction by chewing, those Th17 immune cells just remain dormant, and your barrier against bacterial and fungal infections is severely compromised.
So, bringing all these threads together for you, the listener, we started with the assumption that chewing is just a minor prerequisite to swallowing, but the sources reveal it as the critical biological trigger.
It is the cephalic phase mechanism that initiates the cascade of GLP-1 and satiety hormones. It determines the structural integrity of food gels, controlling gastric emptying. It is the gatekeeper for your agni and strotas, and it physically arms your immune system's Th17 cells.
Chewing 30 to 40 times is not just advice for polite table manners, it is the operating manual for human metabolism.
I want to leave you with one final, deeply provocative concept from the Ayurvedic texts on this. There is a principle called vipaka.
How does the text define vipaka?
Vipaka refers to the post-digestive effect of food. It is how a substance fundamentally transforms your biological baseline over time, long after the meal is digested. For example, the pungent vipaka of turmeric reduces systemic inflammation over months. The sweet vipaka of ashwagandha gradually lowers cortisol. Vipaka is basically the long-term physiological consequence of your dietary habits.
So if we accept that the physical structure of our food and the precise mechanical effort we put into chewing it alters our GLP-1 release, our nutrient absorption, and the gas produced by our microbiome,
Oh,
we really have to confront the modern diet.
we do.
We have shifted completely toward ultra-processed, pre-chewed soft diets. Smoothies, soft commercial breads, protein shakes, processed meat paste. We're consuming thousands of calories that require absolutely zero mechanical effort.
We have engineered diets that completely bypass the cephalic phase. If we remove the mechanical trigger, we really have to ask what we're doing to our long-term vipaka. Could this massive shift towards soft food be the hidden reason our immune systems are struggling, simply since we aren't activating those Th17 cells?
Wow.
Could the modern epidemic of lower gut dysbiosis be directly tied to dumping unbroken down gels into our large intestines?
We are essentially evolving ourselves out of our own digestive process. We are turning off the biological chain reaction before it even starts, simply because we stopped doing the work in our own mouths. So next time you sit down to eat, remember the Lego brick analogy. The mechanics matter just as much as the macros. Put the fork down between bites. Avoid the doom scrolling. Give your body the time to truly experience your food and let your biology do the heavy lifting it was beautifully designed to do.